So now we know the moment. So we know the moment, maximum moment is equal to 1500 Newton meter. We found this out already. Okay. So the next thing that we're going to do, okay, the next thing that we're going to do, which you guys already knew how to do pretty well.
I have a question.
Yes. Hello?
So if we have different support, if we have one fixed support from one side, yeah, can you hear me?
Yes.
Yeah,
I can.
like if we have one fixed support from one side,
Okay.
is the moment going to be the same, like between B and C?
Yes. Okay. What do you mean by fixed? Pin or cantilever?
Pin.
If both are pin, the stress is going to be the same. It will only change if the one side is built in cantilever beam. Okay. Right. Sabah, are you okay with that?
Yes.
Okay. Right. So
So
now, yeah, Justin, you have a question?
yeah, sorry. What if we have more than just the two supports? What if we have another support in the middle? That'll
Okay.
change things as
That
well, right?
yes, that will change things, and that is known as statically indeterminate structure, which you will learn in week the last 2 weeks of the course.
Okay.
Okay.
No rush.
Okay. So now, so what we are going to do now is we're going to find the second moment of area, things like that. Okay. So we know our Mx. So what we're trying to do down here is stress in the x direction is equal to mz over izz multiplied by y. Okay. So we know how the structure will bend. The structure is going to bend this way. Right? We know that. Why the structure will bend this way? Because this is the deformation pattern. Right? It's going to bend this way. That is the deformation pattern. So when that's the case, based on our moment, now this is our moment in our Z again. Okay, so let me draw a transformation. X, Y, moment about Z. Okay, so now we know that, okay, this is compression. Head of the bending moment vector. The tail end is going to be tensile. Right? Okay, so we know anything on top from the centroid. Now we're going to find centroid. Okay, now we don't know where the centroid is. Okay, so now we are going to find centroid. Okay, so centroid about where? YY or ZZ? So from the formula, you know that we're going to find centroid about what? IZZ. Okay, so this is Y and this is Z. Okay, so from here, we're going to find centroid. So we are going to, so if that's the case, this is our what? This is our ZZ. We don't know where is it yet. Okay, we don't know where is it yet. So I'm going to take my datum from the bottom. Okay, that's my datum. And then based on what I taught you guys, this is going to be the width. Over here will be our what? Our depth. Okay, so we have, I'm going to divide this into section like this. So this is 1, 2, and 3. Okay, so section 1, 2, and 3. Okay, so likewise the same thing. So this, you guys have learned all this in shear force, shear stress before, right? So width is 10, depth is 60. Okay, so this will be equal to, so 1 is 600. The same. The other one, the width is 30. The depth is 10, 300. Okay, so over here, 60, 60, 12, 1500. Okay, this 500. Then the next one, you guys should be really good at this by now. Okay, so the next one is your individual centroid. Okay, so all this is equal to 60 divided by 2. 60 divided by 2. Okay, 30, 30, and then the last one is 10 divided by 2. Okay, then you have W D Y bar. Okay, so 600 times 30, 18,000, 18,000. Okay, so 300 times 5, 1,500. So this will be equal to 18 times 2 plus 1,500 is equal to 37,500. Okay, so from here you get your centroid. So 37,500 divided by 1,500. Okay, so 37500 divided by is equal to 25. Okay, so it's equal to 25 millimeters from the bottom. Okay, so from here you find your second moment of area. Okay, now second moment of area. Okay, I will just do it really quick. Okay, I'm aware I'm almost out of time. Okay, I will stop after finding the second moment of area. Now the rest of the procedure are the same as finding the like what I've taught before. Okay, so IZZ. Y'all prefer me to show you the moments of finding? I think IZZ you guys are fine down here. Okay, I'm just going to write the IZZ value. No point repeating myself. So IZZ, okay, is equal to, okay, I'm just going to write the value for you guys. Is equal to 512.5 times 10 to the power minus 9 meter 4. Okay, and then from here, right, we now know. So let me get the cross-sectional area for you again. Let's see, can I copy? Yeah, I want you to see the diagram. So we already know that on top is what? Tensile. No, we already know that on top is compression. Below is tensile, okay? And we know that the centroid is equal to 0.25 millimeters. Right? So now I want to find the stress at point alpha and the stress at point beta. Okay? So we can write this out as stress X alpha. So the moment we found is 1,500. Right? And we know it's minus because we know it's compression. And the distance is equal to 0.06 minus 0.025. Right? Why that distance? Because alpha to the centroid, okay, that is equal to 35 millimeters. Okay? So divide by second moment of area, 512.5 times 10 to the power minus 9. So this will be equal to 1500 times by 0.06 minus 0.025 close bracket divided by 512.5 power minus 9 is equal to, I get 102, okay, 0.439 times 10 to the power 6 Pascal, and stress X beta is equal, so we know that it's going to be tensile, and we know that the Y is 0.025 divided by 512.5 times 10 to the power minus 9. Okay, so 1,500 times by 0.025 divided by 512.5 power minus 9. It's equal to 73.171 times 10 to the power 6 Pascal. Okay, so I'm going to stop here. Okay, I'm going to stop here. Then we will continue again next week. Okay, I'm going to stop recording and then we're going to talk about your term test.